All right, hello there. I'm going to go ahead and go over this review sheet with you. So this is a square root function, and it's important to note right here that this is the point -5, 0. So a normal square root function looks like this. It is starts at 0, 0 and kind of curves up to the right, gets higher and higher and higher. So this graph has been reflected over the x-axis, and it has been shifted to the left 5. So the transformations, reflection over the x-axis and left 5. My domain, my x value is starting at -5 and going off to the right, going off to infinity, and then the y value is going down to -infinity. So my x values are -5 to infinity. My range, though, is -infinity to 0. 0 is the highest place, the -infinity is the lowest. So -infinity comes first, and 0 comes next, because you go from smallest to largest. All right, the end behavior as x goes to infinity, so as this graph goes to the right, then the graph goes down. Sorry, I was looking for my pointer here. Where is that thing? There it is. So as you go towards infinity, this direction, the graph goes down, 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 down. So my end behavior is -infinity. The equation, we're going to take these two transformations. Oops, I already have g of x equals. So I just need a square root. I need x plus 5 to move it left 5, and a negative in front to move it, to reflect it. All right, for number 2, I need to break down 160, so I'm going to do that over here. 160, how about 16 times 10? 16 is a perfect fourth root, if you notice that, but if you don't, you'll have to break it up into 4 and 4, and 2 and 2 for each of those. And this one's 5 and 2. So you can tell right here that a 2 comes out. Got 4 of them. So 2 comes out, and the 5 and the 2 stays in, so 10 stays in. So 2 comes out with a 7 that's already there. So 2 times 7 is 14. You already have an A. And I'm going to leave a little bit of space, put my fourth root back, and put the 10 back in. Now, this 4 goes into 6 once, so I'm going to bring another A out. That means I have 2 A's outside. And when I put 4 into 6, there's 2 left, so there's 2 inside. All right, and then 4 goes into 2, not at all, so B2 stays inside. And 4 goes into 12 exactly 3 times, so C3. There you go. So now, number 3, to subtract. If you plan on subtracting, your radicals have to look exactly the same. The outsides, the insides have to be similar expressions. So, like this first one, 81. If I go down to here and break out 81, 81's 9 and 9. And 3 times 3 for each of those. So obviously, I have 3 3's, right? Because I'm doing cube roots. So bring a 3 out, there's already a 5 waiting, so that'll be 15 with an x. Put my cube root back, there's still a 3 left inside, and the x that's in there can't move. Now over here, this one's a little bit easier. 3 inside right there stays, so 2 is going to stay the same. I'll have my cube root of the 3. Now this 3 goes into 4 one time, and there's 1 left. And so now when you look at these, you see how they're an exact match. So all I have to do to finish this off, I have 15x minus 2x, and then the cube root of 3x just sticks around. So 15 minus 2 is 13. So 13x cube root of 3x. And that's done. All right, for number 4, we're going to try and solve these. So I'm going to clean them up. Add 12 here. So I get 5 cube root of 2x plus 1 equals 15. Divide by 5. So cube root of 2x plus 1 equals 3. That's fine. So now I'm going to cube both sides to get rid of my cube root. All right, so when I cube both sides, this 2x plus 1 pops out, and 3 to the third is 27. All right, so from here I take away 1, so I get 26, and then I get 13 when I solve that. All right, and maybe I'll make that a little bit better looking. Now, going on to the next problem, I'm going to have to take away 10 from both sides to clean this up. But when I do that, I notice I get negative 2 equals the square root of x minus 7. Now you could go and square both sides, but you wouldn't be correct to do that because a square root can never equal a negative number. So this right here, you should notice, is no solution. Nobody's going to stop you from squaring both sides. You have to stop yourself. All right, looking here. The 6th root of 4096. So if you start breaking, or you go in the calculator and do the 6th root of 4096, or in Desmos, you do get 4. So right away I know that it's one of these two answers. Okay, 4 to the 6th is 4096. You do not divide 4096 by 6. So then 6 goes into 19, not at all. So 19 over 6, that looks good. Oh, this one's wrong. And then 6 goes into 13. This is how I show that. So letter C it is. All right, number 6. I'm going to have to multiply these together. So I get one big 4th root. I get 81. X to the 8th and y to the 6th. All right, 81 is a perfect 4th power. You noticed how it was 9 times 9. Each of those 9s were 3 and 3. So 81 is 9, 9. And then each of those is 3, 3. So obviously a 3 is coming out. 4 goes into x8 twice. And 4 goes into y6 once with 2 left. So there's a y squared left inside, and don't forget to write the 4. All right, here. Two things you could do here. A radical 7x times a radical 7x. You know that's the same and it's a square root, so out pops a 7x. You could know the answer right away that way. Or you could actually do the multiplication. You get the square root of 49 x squared. Well, the square root of 49 is 7. The square root of x squared is x, so same answer. All right, number 8. Polynomial. It's in factored form. So what we want to do is we want to find all the zeros. So remember, to do this, you take each part set equal to 0. So x minus 2 equals 0. Solve that. 3x plus 1 equal to 0. Solve that. 5x minus 3 equal to 0. Solve that. All right, so if you solve x minus 2 equals 0, you add 2 to both sides, so you end up getting x equals 2. 3x plus 1, you take away 1, divide by 3, so you get negative 1/3. 5x minus 3, you add 3, divide by 5, and you get 3/5. All right, find the inverse. So remember, f of x is the same thing as y. So to find the inverse, you switch the y and the x, so you get x equals y plus 5 cubed minus 2. So now I'm going to solve for y. Add 2, so I have x plus 2 equals y plus 5 to the 3rd. Now to get rid of the 3rd power, I do a cube root on both sides. So over here we have a cube root of x plus 2 equals y plus 5. All I have to do is pop that 5 to the other side, basically subtract it from both sides. So my answer is y equals cube root of x plus 2 minus 5 on the outside. Okay, now just to do it, professionally, you should write it like this. You should write that the inverse is f negative 1 of x equals, and then write your answer, cube root of x plus 2 minus 5. That would be the best, most perfect answer that you could have right up here. All right, number 10. Number 10, we're trying to graph the cube root function. So the cube root function goes right through 0, 0, 1, 1, goes 8, 2, and negative 8, and negative 2. Cube root function looks like this. Remember, you can always go to Desmos and graph that as well. If I want to move it left 5 and up 2, okay? So I'm going to do that graph. Left 5, up 2 would be my center there. And then my graph would come through like this and go up right through there. Okay. All right, let's see. This guy, so 125, remember 1/3 means the cube root. So I got 125 to the 1/3 power. Remember what you do with your exponents here. You multiply the 1/3 times this exponent. So 1/3 of 9 is 3, so A3. B, 2 times a third would be 2/3. And c, 0 times a third would just be 0. So the c is just to the 0 power. That's just equal to 1. So it pretty much disappears. So these answers with c to the 1/3, that's not right. All right, so let's take a look. 125 to the 1/3 power is 5 because the cube root of 125 is 5. So I'm going to choose letter D. And the last question here, 4x to the third plus 100x. Factoring out the GCF, well, 4 goes into both 4 and 100, so I'm going to take out a 4. And I'm also going to take out an x. So that would leave me with x squared plus, and then 100 divided by 4 is 25, and the x is already outside. So there we go. And we can't factor anything else. X squared plus 25 is not factorable. If it was x squared minus 25, we could, but we're done. And also the problem said to just factor out the GCF. So there we go. All right, bye-bye.